National 5 Electricity Practice Test Solutions. Multiple choice section. Question 1. 4 circuit symbols W, X, Y, and Z are shown. Which row identifies the components represented by these symbols? We look at the components one at a time. Component W is a lamp, which means A and B are out. Component X is a voltmeter, which means C is out. Component Y is a resistor, which means E is out. And just to check, component Z is a fuse, which means the answer is D. Question 2. The voltage of an electrical supply is a measure of A, the resistance of the circuit, B, the speed of the charges in the circuit, C, the power developed in the circuit, D, the energy given to the charges in the circuit, or E, the current in the circuit. Well, the resistance of the circuit, the current in the circuit, and the power developed in the circuit are measurements of themselves, so they're all incorrect. The speed of the charges in the circuit can be considered as the current. So voltage, the voltage of an electrical supply, is a measure of D, the energy given to the charges in the circuit. The ratings plate on an electrical appliance is shown, and we're asked to calculate the resistance of the appliance. So our first step in every calculation question is to write down what you know. The information on the question that we're given, V is equal to 230 volts. We're also told the frequency of the supply is 50 Hertz. And we're told the power of the supply is 920 watts. The value that we wish to calculate is resistance. If we look at our relationship sheet, we can see an equation for power, which involves terms of voltage and resistance, and that is P is equal to V squared over R. Substituting in the values, we end up with 230 squared over R is equal to the power, which is 920 watts. We can rearrange this and say that R is equal to 230 squared over 920, which gives us a value of 57.5 ohms, which is E. Question 4. 2 circuits are set up as shown. Both circuits are used to determine the resistance of resistor R. Which row in the table identifies meter X, meter Y, and meter Z? Now you've done this experiment in class, so you should know that meter X, used to measure resistance directly, is the ohm meter, which means that C, D, and E are all incorrect. Meter Y is connected across a component, and meter Z is measured through a component. We know from our experiment that in order to calculate resistance, we need values of voltage and current. Because meter Y is connected across the component, that must be the voltmeter, which means that A is correct, B is incorrect. Just to check, meter Z must be our ammeter, which confirms that the answer is A. Question 5. A student makes the following statements about AC and DC circuits. In an AC circuit, the direction of current changes regularly. In a DC circuit, negative charges flow in one direction only. And in an AC circuit, the size of the current varies with time. You're asked to identify which of these statements are true. Let's remind ourselves a little bit about AC and DC. Remember, in an AC signal, we see the current change in direction regularly, and we also see its amplitude changing in value, which means that statement 1 and statement 3 are correct. In a DC signal, we see the flow of current in one direction only. That one direction tends to be from the negative terminal of the battery, therefore it's the flow of negative charges. In a DC circuit, negative charges flow in one direction only. The negative charges are the electrons, so statement 2 is also correct, which means our answer is E. Question 6. Circuit is set up as shown. Determine the resistance between X and Y. Now, if we have a look here, we have a series component and parallel components. In order to answer this question, we need to work out the parallel component first. 4 ohm and 4 ohm in parallel gives us an overall resistance of 2. Because remember the general rule, if I'm combining resistances of the same value in parallel, then the total resistance is equal to the value of the resistance divided by the number of resistors. So in this case, the resistance of my parallel section is equal to 4, because that's the value of the resistors, divided by 2, because that's the number of resistors I have, which gives me 2 ohms. The total resistance is calculated using the series rule for resistance, so that's going to be equal to 4 plus the parallel component, which is 2, which gives us 6.0 ohms. C. Question 7. We're shown the path taken by a particle as it goes past other charged particles Q and R, and we need to identify the charge on the particle, the charge on Q, and the charge on R. Well, first of all, we can see that within the path, there's a point here where the particle is attracted towards particle Q. That means that the charge on particle Q must be opposite to the charge on the particle taking the path. So let's have a look at that in our options first. In our options from A to E, we're looking for the charge on the particle and the charge on Q to be the opposite of each other. So A is a possibility, B must be incorrect because they have the same charge. Similarly, E must be incorrect because they have the same charge. Now, as well as being attracted to particle Q, we can see at this point our particles being repelled by particle R. That means that the charge on our particle taking the path must be the same as the charge on particle R. So I look for options where the charge on the particle and the charge on R are the same. Option A is incorrect because we have positive and negative. Option C is incorrect because we have negative and positive, which leaves us with D. Question 8, we have a graph showing how the resistance of a thermistor varies with temperature. We're also told that at a temperature of 50 degrees C, the current in the thermistor is equal to 0.04 amperes. At this temperature, the voltage across the thermistor is, that's what we want to calculate. First step in every calculation question is to write down what we know. We know that the current is equal to 0.004 amperes, and that's at a temperature which is equal to 50 degrees C. We also know that we want to calculate voltage. The graph will allow us to find a resistance value at a temperature of 50 degrees C. So we follow the graph at 50 degrees C. Here we know we have a current of 2 kilo ohms. So we have to remember our conversions of units. So R is equal to 2 kilo ohms, which is 2,000 ohms. It's then a straightforward Ohm's law calculation. V is equal to I times R. 0.004 multiplied by 2,000, giving us a value of 8 volts. Now, although this seems very straightforward, this question is often done wrong. And that's because either there's mistakes written in transcribing the 0.004 amperes onto your paper, or more commonly, instead of taking into account that the values in resistance are in kilo ohms, you simply put in 2. Be careful of units. Be careful of the number of zeros within your numbers. Question 9. A circuit is set up as shown. You're told readings on ammeter A1 and A2, and you're asked to find the charge passing through the lamp in 30 seconds. So I want to find Q. Now, the time we're given in the question is 30 seconds. So in order to find Q, we need to find I. Well, if I've got 5 amperes here, and 2 amperes goes this way, that means that I must have 3 amperes going through my lamp. So I is equal to 3 amperes. The equation is Q is equal to IT, which is equal to 3 multiplied by 30, giving me 90 coulombs, or D. Question 10. The student sets up the circuits below. In which circuit will both LEDs be lit? Now remember, the rule for an LED, LEDs are very depressing. They always focus on the negative. We want the arrow part of the LED to be pointing towards the negative terminal of the battery. The negative terminal of the battery is the short side here. So if I have a look at circuit A, my first LED, that's pointing towards the negative, that's fine. However, my second LED is not. Looking at circuit B, my first one, yes, that is pointing towards the negative, so that's fine. The second LED, however, is not pointing in the right direction, so that doesn't work either. In C, the first LED, the one at the bottom, is pointing towards the negative, so that's fine. The other one's pointing towards the positive, so that's wrong. Then I look at D, back end of the bottom LED, focusing on the negative, so that one's incorrect. This one at the top is pointing towards the positive terminal, so that's incorrect as well. And then option E, first LED in the bottom is pointing towards the negative, and the LED at the top is also going towards the negative. So our answer is E. Section 2. Question 1A. A toy car contains an electric circuit which consists of a 12-volt battery, an electric motor, and 2 lamps. That circuit is shown on the diagram. Switch 1 is now closed. We need to calculate the power dissipated in the motor when it operates. First step in every calculation question is to write down what we know. We're looking at the motor. The motor is connected in parallel with 12-volt supply, so I can say that V is equal to 12 volts. The motor has a resistance of 100 ohms, so I could say R is equal to 100 ohms, and I want to calculate power. So this is very similar to the question we did in the multiple choice. Our equation from the relationship sheet is P is equal to V squared over R, which is equal to 12 squared divided by 100, giving us a value of 1.44, remember your units, watts. 1B, part 1. Switch 2 is now closed. Calculate the total resistance of the motor and the 2 lamps. So first of all, write down what we know. We know the first resistance is 100 ohms. Second resistance is 50 ohms. And the third resistance is also 50 ohms. We're looking at a parallel circuit here. So the resistance rule in parallel, 1 over RT is equal to 1 over R1 plus 1 over R2 plus 1 over R3. So that's 1 over 100 plus 1 over 50 plus 1 over 50. Now, we always recommend that you use the fractional method for this calculation, so you can put those fractions into your calculator, or you could do it in your head and have a look at common factors, what I'm going to do is I'm going to turn these 50s into hundreds, so we have a common denominator. So we end up with 1 over 100 plus 2 over 100 plus 2 over 100, which gives me 5 over 100, or 1 over 20. And that's what you would find on your calculator. Now 1 over RT is 1 over 20, so we have to flip and say that RT is equal to 20 over 1, which is of course 20 ohms. 1b part 2. One of the lamps now develops a fault and stops working. State the effect this has on the other lamp. You must justify your answer. So must to justify is a command word at National 5 and basically says if you do not try to justify your answer, you can't get it correct. If you get the answer correct, your justification is not enough but is not wrong, then you get 1 mark out of 2. If you justify and you use wrong physics, you get no marks. If, of course, you justify with correct physics, you get both. So if we take away one of the lamps and there's a fault, then what happens to the total resistance? Well, remember the rule, in parallel, if we add a resistance in parallel, then the overall resistance goes down. So in this case, we're taking away a resistance in parallel. That means the total resistance is going to go up. If the total resistance goes up, that means the current is going to go down. And if the current goes down, that means the brightness of the lamps is also going to go down. Now, when we're thinking about practice questions like that, it's absolutely fine to use the arrow notation and bullet points. But the SQA doesn't like bullet points. They would be expecting you to write in sentences. A solar jar is designed to collect energy from the sun during the day. This is question 2. When the solar jar is placed in sunlight, photovoltaic cells, energy conversion of sunlight to electrical energy, are used to recharge the battery. At night, the rechargeable battery is used to power 4 identical LEDs, light emitting diodes. Here's the circuit. In direct sunlight, the photovoltaic cells produce a combined voltage of 4 volts. Calculate the voltage across the 18 ohm resistor. First step in every calculation question, write down you know. We know that supply voltage coming from the solar cells is 4.0 volts. We also know the resistances within our potential dividers. So R1 at the top is equal to 2.0 ohms. R2 at the bottom is equal to 18 ohms. And it's that one that we're really interested in. We want to find the voltage across the 18 ohm resistor, so we want to find V2. Our equation is the potential divider equation. V2 is equal to R2 over R1 plus R2 multiplied by Vs, which is 18 over 18 plus 2, which is 20, multiplied by our supply voltage, which is 4. This gives us a value of 3.6 volts. Question 2b, part 1. Switch is now closed and the LEDs light. State the purpose of the resistor connected in series. Well, what does a resistor do? A resistor limits current, and that's the purpose of the resistor within the circuit. To limit current through the LED. We could also say, as well as limiting the current, it also limits the voltage across it. Effectively, we're limiting the amount of energy that the LED gets so it doesn't overheat. After a few hours, the rechargeable battery produces a voltage of 3.4 volts. So let's write that down. Vs is equal to 3.4 volts. At this point in time, the voltage across the LED is 1.6 volts. VLED is equal to 1.6 volts. And the current in the LED is equal to 25 milliamperes, but I don't like amperes. I want amperes, so that's 25 times 10 to the negative 3 amperes. I'm asked to find the value of R. Now this is a 4 marker. This is an A-type question. If I want to find the resistance of R, I need to know the voltage across R. This is a parallel circuit. So the voltage across the rechargeable battery is the same as the voltage across each branch. So the total voltage in any one branch, that's any one section here, is equal to 3.4 volts. That 3.4 volts is being split between the LED and the resistor. The voltage across the resistor is equal to the supply voltage, take away the voltage across the LED. Now that gives you 1 mark. So I end up with 3.4 take away 1.6, giving me a value of 1.8 volts. So 1.8 volts is the voltage across the resistor. Then in order to find the resistance of the resistor, I just do R is equal to V over I, which is 1.8 divided by 25 times 10 to the negative 3, remember milliamperes, which is 72 ohms. Now if you don't do the first part, where you calculate the voltage of the cross of the resistor, you will lose 3 marks. You'll only get 1 mark for the use of the equation. Question 2c. When the battery is completely discharged, it takes 6 hours of direct sunlight to fully charge the battery. During this time, there is a constant current of 0.13 amperes to the battery. Calculate the total charge supplied. First step in every calculation question, write down what you know. So Q is what I want to find out. Current, we're told, is 0.135 amperes, and the time is 6.0 hours, but I don't like hours, so that is 6.0 multiplied by 60 multiplied by 60 in order to give us a value of time in seconds. Now we could calculate this here if we wanted to, or we could wait. I'm actually going to wait in my calculation. I'm just going to say Q is equal to IT. I'm going to say that's 0.135 multiplied by 6 multiplied by 60 multiplied by 60. So I've got it all in one line. When you calculate that out, you end up with a value of 2916 coulombs. Now it's perfectly fine to have 4 significant figures here because my value for current is 3 significant figures, and the SQA allows 2 more and 1 less. Question 3a. A circuit diagram of an electronic system is shown below. The system is designed to sound a warning light when the light intensity falls below a certain level. Component X is a transistor. 2 types of transistors are suitable for the system: an NPN transistor or an N-channel enhancement MOSFET. Draw and name the circuit symbols for each. Okay, so our NPN transistor, we have a line, 2 diagonal lines coming out, going down, and an arrow. So that's our NPN transistor. Our MOSFET is a little bit different. Vertical line, and then 3 smaller vertical lines. Top one goes up, the other 2 go down, and I have an arrow pointing in to the center here. And that's my N-channel MOSFET. Now we do have other types of transistors. We do have PNPs and we do have P-channel MOSFETs. However, the N-channel MOSFET and the NPN transistor are the ones that specifically they're laid out within the National 5 guidance for you to be able to state. What is the purpose of the transistor in the system? The transistor acts as an electronic switch. That is, when the transistor gets to a certain potential, it will turn on and allow current to flow to the buzzer. A MOSFET is used to position X. When the light intensity falls, the voltmeter reading rises to 2.4 volts and the buzzer sounds. Calculate the resistance of the LDR when this happens. So the voltmeter is recording the voltage across the LDR. So we can say V LDR is equal to 2.4 volts. The supply voltage Vs is equal to 9 volts. We want to find the resistance of the LDR. Now, the best way to do this would be to use our ratio equation for potential dividers. But in order to do that, we need to first of all find out what the voltage across the 5.5K resistor is. The 5.5K resistor and the LDR are connected in series with each other, so the sum of the voltages across those components must equal to 9 volts. If the voltage across the LDR is equal to 2.4 volts, the voltage of the resistor must be 9, the supply voltage, take away 2.4. 9 take away 2.4 gives you a value of 6.6 volts. The ratio equation for potential dividers is R1 over R2 is equal to V1 over V2. In this instance, we're saying R1 is the 5.5K resistor, so that's 5,500. And R2 is the resistance of the LDR. Voltage 1 is the voltage across the 5.5K resistor, which is the 6.6 volts we just calculated. And the voltage across the LDR is 2.4. We then need to cross multiply. Cross multiply, then we can say that R2 is equal to 2.4 times 5500 divided by 6.6. So when you cross multiply, whatever's opposite what you're trying to find out, in this case we're trying to find out R2, so opposite that is 6.6, that goes on the bottom line, and the other two are multiplied together on the top line. Put all this into your calculator, do your brackets here, saves you making any mistakes, and we end up with a value of R2 to be 2,000 ohms, or we could say 2 kilo ohms. Question 4. A student sets up the following circuit to investigate the resistance of resistor R. Now you've done this experiment. This is the Ohm's law experiment. The variable resistor is adjusted and the voltmeter and ammeter readings are noted. The following graph is obtained from the experimental results. So we have the graph here of current and voltage, and we're asked to calculate the value of the resistor R when the reading on the voltmeter is 4.2 volts. So the first step in every calculation question is write down what you know. We know that V is equal to 4.2 volts. We then need to use the graph to determine the value of the current. So we can see from the voltage scale we have 5 divisions per volt, which means each division is 0.2 volts. So here is 4, 4.2 is here. Follow that line up. We have a reading here and it's exactly in between 2 divisions. Now we can see here is 0.07, here is 0.08. Our point is exactly in between 0.07 and 0.08. It's very clear from the diagram that it's not on the edge of a single division, it's in between. So the SQA would only accept you to have an answer that's plus or minus 0.01. Ideally, we were looking for a value of the current to be 0.075. Now with the values of voltage and current, I can find resistance. Ohm's law, R is equal to V over I. So that's 4.2 divided by 0.075, giving me a value of resistance as being 56 ohms.